Hello everyone. In this session, I'm going to demonstrate you one of the simplest algorithm, which is Naïve Bayes algorithm. So this algorithm falls under the category of supervised machine learning, and it is popularly known for text classification. But we can also use this for structured data, right? So it is used for to develop a predictive model, and this is the simplest algorithm which is based on prior beliefs, or in other terms we can say probabilities. So as per this Jason Brownlee, he has stated that it's a supervised learning approach. You will come up with when you want to build a predictive model that is probabilistically. So this is based on some mathematical logic here, and we need to get the probability. So the formula for that is this one. So before that, we need to understand the terminology here. When you consider some event A, right? So the prior probability. So in other terms, we say belief of the event A. Then the probability for that is denoted as P of A, probability of A. So when you have a new evidence, when you have got some new evidence, we denote that as X, and which might affect the probability, right? So given evidence X, we can calculate a new event A. We can calculate a new event A, and that is called as posterior probability. So on evidence X, you are getting the new probability, and we are calling that as posterior probability, which can be denoted as probability of A on X. So right, that means the probability of event X on event A on X. So we can observe this. That is the probability of X on A. That means the probability of observing the event evidence X for the event A, and P of X, that means that is simply the probability of the evidence X. So finally we'll be getting the probability of event A on X, which is equals to probability of X by A multiplied by probability of event A multiplied by probability on event X. So when you get this, you'll be getting the probability, and this algorithm is based on the probability only, right? So there are four types of classes which can be built by using a Naïve Bayes algorithm, and that is provided by scikit-learn library, and these are the types of algorithms. So Gaussian Naïve Bayes, and here the model assumes that the features in the data set are normally distributed. So when the features are not normally distributed, so you cannot go for applying Gaussian Naïve Bayes. And the second one is multinomial Naïve Bayes. So it is used for document classifications. Importantly, when you have multiple documents, right, that means multi-class classification. In that case, you can use multi-class Naïve Bayes algorithm. And here there is an assumption, that is a data set is multinomially distributed, means multiple distributions. And complement Naïve Bayes. So this is used when your data set is imbalanced. That means your class values are imbalanced. That means majority of the samples belongs to positive or negative. In that case, you can go for applying complement Naïve Bayes algorithm. And the last one is Bernoulli Naïve Bayes. So this is used when you have more than two or more features. When you have two or more features, and they are assumed to have binary variables, right? It means binary classifications. And here I'm just letting you to know the different applications of this algorithm. So this can also be used in real-time data analysis. So it's one of the simple algorithm which is used for analyzing the real-time data. That means you can make the predictions in real time. And also this is used for multi-class predictions. When you have multiple outcomes, and your main emphasis is on the probability values. And as I mentioned at the beginning, it is used for text classifications, or spam filtering, means binary classifications, and also it is used in sentiment analysis. So to know the email is spam or not, means binary classifications, the different types of sentiments like positive, negative or neutral. In that case, you can build a predictive analytical model by using a Naïve Bayes algorithm. And this can also be used in developing a recommendation system where you can recommend a product like you can go with that or not, yes or no, recommended or not recommended. So in that case, it is also popularly used. And these are the pros and cons of the algorithm. So the advantages are it is a relatively easy algorithm. This is one of the simplest algorithm which can be used for building the model, and it is also faster to predict classes using the algorithm than you have than many other classification algorithm. That means it is one of the simplest algorithm which is a little bit fast and can be easily trained using a small data set. So when you have a larger data set, so this algorithm might not be helpful. Then what are cons? So means the disadvantages. So if when you have a class and the features have zero frequency, then the conditional probability will be zero. That means your outcome is also can be infinite. So this problem is called as zero conditional probability problem. So this problem is this problem can be wiped out by finding the probabilities too, but there are several sample correction techniques which can fulfill this problem. For example, Laplacian correction. And one of the another disadvantages, and it's very strong assumption that independent class features are there. That means all the features are independent. When you have dependent features, this algorithm is not going to helpful. So these are the plus and minuses of this algorithm, and remember it is popularly used for these scenarios or these applications. In simpler terms, it is good for text data. So in order to demonstrate, I'm just using a sample dataset which is downloaded from Kaggle. So also this is available on so many open data platforms, right, like UCI, and the dataset has been downloaded from there. And then as usual, we import pandas to create a data frame. So right, it is imported, and this is my file diabetes.csv. Loading the diabetes data from my data folder, then creating a data frame. So here my problem statement is diabetic prediction, whether the person has a diabetic or not based on the features in the data set. And then displaying the header part of the data. So this is how the data looks like, and this is my target variable outcome, which has the values 0, 1, yes or no, the person has diabetic or not, based on the attributes like this pregnancies, glucose values, blood pressure, so like the BMI, insulin. So based on this you can determine the value for outcome. And what about the value count? So I'm checking the data dot outcome, means this column dot value count. So how many sample belongs to 0 class and how many samples belongs to 1 class. So majority of the sample belongs to 0 class and the number of samples belongs to 1 class is less. Then checking the data types. So these are the variables, and you see these are the integers 64-bit, and these two BMI and diabetic no predictive function. This one is also float. These two are float, and the rest of the variables are integers 64-bit. And having a descriptive statistics of the data, you can say the maximum age is 81 and the minimum age is 21. Average age is the mean age 33.24. So we are having a descriptive statistics for each variable. Descriptive statistics simply describe your data with these measures like count, mean, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and then maximum. So this is just clean data, so I'm just separating the features into X and Y. So dropping the outcome column, axis 1 means column, so dropping the outcome column, the last column, and rest of the features are assigned to X, and Y is the target variable in which I'm putting outcome. So right, these two are no, that means data is separated, and then importing the class train test split from the module scikit-learn dot model selection, and splitting data, splitting x and y into 70% and 30%. Here test size is 30%, means 70% is training, and random state I am mentioning as 0. You can split the data into 60-40 or 70-30 or 80-20 or 90-10. So as per machine learning, so minimum no 50% of data is used to train a model. So more data training, more learning, right? So data plays a major role when you build a powerful model. So once the data is splitted, I'm just simply importing the algorithm here, Gaussian Naïve Bayes, from the module scikit-learn dot Naïve Bayes, and then creating an object to the class, right? And then fitting the data, xtrain dot xtrain. So model always learn from the training data. So model dot fit xtrain dot ytrain, then making the prediction for 30% test data. So once the predictions are made, then I think I didn't run this, so I must run this cell first. Right, this is done. So prediction is done, and then you need to evaluate your model. So importing the metrics like accuracy score, classification report, and confusion matrix from the module scikit-learn dot metrics, and here I'm displaying the accuracy. So the accuracy is 76%. Right, the accuracy is 76%, and you can also have a more detailed classification by using the metric classification report. So you can see the average accuracy is 76%, and you can check other metrics like precision and recall, and also F1 score. So F1 score is harmonic mean of precision and recall, and you can see for 0 class the F1 score is 0.83, for 1 class the F1 score is 0.58, means 58%. So we always prefer a model to have a good F1 score. That means the recall values should be higher for both the classes, right? And finally, you can also have a confusion matrix to know how many samples are classified into 0 class, and how many samples are classified into 1 class, and how many samples are misclassified. So here 19 samples are misclassified into 0th class. So 138 is the successful and 19 is misclassification. Then 38 samples are classified into 1 class, and 36 samples are misclassified. So I don't want to apply any other algorithm, so I just want to demonstrate I just want to use Naïve Bayes algorithm on simple data set, that is a diabetic prediction, right? So we have built a model, and we finally check the accuracy, that is 76%. So you can do data pre-processing, and you can also do apply some hyperparameter techniques. Instead of splitting data into 70-30, you can make it 80-20, or you can make it 60-40, and you can also change the random state value here, right? So that you can build a powerful model, and your accuracy might be higher than me, right? So this is a simple process how do you apply a Naïve Bayes algorithm. So that's it from me today. So do like our videos and subscribe, so that we can come to know whether we are on right track or not, and the feedback always plays an important role. And do subscribe our channel for more updates in the near future.